Hello, and a warm welcome to this very first episode of the Kielder Observatory podcast. I'm Ian Brannan, and together with a couple of Kielder's science communicators, Dan Pye and Adam Shaw, we've got some great things on the way. Coming up in this episode, after the news of possible life on Venus, we speak to Professor Wallace Arthur, who's a leading expert on the chances of finding life in other worlds. But he believes other worlds have already found us.
In the vastness of the universe, there are simply so many planets, it's probably a one with at least 20 zeros after it, that there will be some planets where life has evolved beyond the stage that it has here. So yes, I think probably other life has discovered us.
We'll take you on a virtual audio tour of the observatory.
Okay, so I'm going to turn the telescope on. So we've got a little switch which turns it on. It makes some little R2-D2 noises.
And we'll take a look at the month ahead and find out what we can expect to see, both in the night skies above the observatory in the Dark Sky Park, and from the comfort of our own gardens. But first, we're going to delve into one of the big space discoveries of the past few weeks. As we mentioned, you might have seen this news headline: Is there life on Venus? Scientists think that they have found some evidence of life. Someone who can tell us more is Adam Shaw. First up, Adam, this is very exciting, particularly because Venus is not particularly the most hospitable environment in the universe.
Yeah, it's incredibly exciting because Venus is not the sort of... if you know anything about Venus, when I'm talking about Venus in schools to kids, one of the main things I go to is how horrible a place it is. It's incredibly hot, there's toxic gas in the atmosphere, the pressure from the atmosphere can crush you. Just in general, it's not a nice planet to go to. But it's incredibly exciting because some different astronomers confirmed the existence of quite a large amount of phosphine gas in the atmosphere of Venus, and this can be caused by natural causes, but the significant amount that has been discovered could be linked to natural or biological processes, and therefore could be a sign that life could exist in some form or another in the atmosphere of Venus or on Venus itself.
Well, for more on this, we have our guest with us in this episode. Wallace Arthur is Emeritus Professor at the University of Ireland in Galway. He's also written a number of books, including Life Through Time and Space, published by Harvard University Press, and The Biological Universe, which has just been published, would you believe? So what a time to have this news break, Wallace, of biological life possibly being found on Venus. It's the perfect promotion for your book.
Well, I have to tell you that no money changed hands between myself and the authors of this article. I have to admire their timing. For me, it's great. So anyone who's drawing attention to the possibility of extraterrestrial life in the immediate post-publication period of the biological universe has my full support.
I imagine it does. This, though, on a serious note, though, it must have come as a bit of a surprise because, as Adam mentioned just there, Venus not the most hospitable, and obviously welcome news for you, but surprising nonetheless.
The gas that was discovered is called phosphine, and I guess, as Adam said, there was a lot of it discovered if you think in terms of counting molecules. However, its concentration is incredibly low. It's actually way, way less than 1 part per million in the atmosphere. And so it's, in terms of being evidence for life, it's interesting because phosphine's got no right to be there on Venus because it's the kind of atmosphere which should attach oxygens to phosphorus and not hydrogens. And so it's already known that there's phosphine in the atmosphere of Jupiter, but that's not surprising because that's a different kind of atmosphere, and phosphine can be produced there relatively easily, non-biologically, but by ordinary chemical processes. On Venus, the atmosphere is so different, we would not expect any phosphine at all. It should be something like phosphates. And so the question is, how did it get there? And if we look on Earth at phosphine, it's only produced in 2 ways, either industrially, for a variety of reasons, or by the kind of microbes that you find in anaerobic locations, such as the mud at the bottom of ponds. So these particular microbes can produce phosphine gas, and that's why the authors of this particular paper in the journal Nature Astronomy argued that one possibility for the production of phosphine in the atmosphere of Venus is Venusian microbes. Now, personally, I think that's unlikely, but it is a possibility, and so hence the excitement attached to this particular finding.
When we get news notifications on our phones from news organizations saying life has potentially been found on Venus, I think your mind immediately goes to science fiction movies and you think of little green men running around Venus. But we're talking microbial life here. But that itself is a very significant advancement in the search for any life beyond Earth, isn't it?
Yes, it's fairly certain that there are no little green men on Venus. However, as of now, we have no evidence for any extraterrestrial life of any kind anywhere, and that includes microbes. So even to find simple microbes, things like bacteria, elsewhere than the Earth would be an absolutely amazing finding. And therefore, the excitement attached to this finding of a gas, which could be produced by microbes, but my guess is that it's probably produced by some chemical process that we haven't discovered yet. And I would urge those people who are excited, like me, in the possibility of extraterrestrial life, not to go overboard about this particular discovery, because I think what's much more likely to be our if you like, our arena for discovering our first extraterrestrial life is not planets in our own solar system like Venus or Mars or Saturn, but rather these enormous numbers of exoplanets that we've discovered orbiting other suns than our own. And as listeners may know, we've now discovered between 4,000 and 5,000 of these exoplanets. And that's from the starting point of only knowing about a dozen of them at the turn of the millennium. So this has just been an amazing addition to human knowledge. And among the 4,000 or 5,000 planets that we've discovered outside our own solar system, there's almost certainly life on some of them.
How far away do you think that we are now with those discoveries over the last 20 years that you mentioned to actually discovering something substantial on this particular topic?
Well, I've actually said in my book that it's quite likely that we'll discover our first evidence for extraterrestrial life either this decade or the next. And one of the reasons I'm confident about that is not just the discovery of all these exoplanets, which gives us lots and lots of possibilities, but also the next generation of space telescopes that are now in advanced stage of planning and will be either approved or not. And there's a bit of a cliffhanger here because NASA does these decadal surveys, and there's one due soon to decide whether or which of these next generation space telescopes go ahead. There's one, for example, called HabEx, just obviously short for habitable exoplanets. And once these telescopes get going, our ability to detect the signatures of life in the atmospheres of other planets will multiply enormously. And I think we're really getting quite close now to getting persuasive evidence for life existing on exoplanets.
Do you think life on other planets has discovered us yet?
Almost certainly yes, simply because of the scale of the universe. So most astrobiologists would say, well, planets with microbial life will be far commoner than planets with intelligent life, and I absolutely agree with that. But in the vastness of the universe, there are simply so many planets, it's probably a one with at least 20 zeros after it, that there will be some planets where life has evolved beyond the stage that it has here. So yes, I think probably other life has discovered us, but it may well not be in our own Milky Way galaxy. It may be much further afield. And these vast distances, of course, cause huge problems in communication.
And that is the issue, isn't it? The sheer vastness of space and so much of space that we don't understand. Do you think that we will ever get so deep into space that we will ever discover this intelligent life that may be more advanced than us?
That's an incredibly good question. I'm really not sure what the answer is. I mean, the current best guess as to the number of galaxies, the number of Milky Way-like units in the observable universe, is 2 trillion. So the scale of the universe, even just what we call the observable universe, is huge. 2 trillion galaxies, and if each galaxy is, ballpark like the Milky Way, give or take, you're talking something like 1 trillion planets per galaxy. So the mind boggles, really. The scale of things is incredible.
And while we always focus on more superior life, I suppose, and intelligent life, there is a chance that we uncover a world eventually that actually is more prehistoric than our own, that we're back to the early era of life on a planet.
Oh, sure. And I mean, microbes, looked at from one perspective, microbes are prehistoric because they were the first forms of life on Earth. But looked at from another perspective, they're absolutely not prehistoric. They're very modern because most life forms on the planet today, on Earth that is, are still microbes. We're very successful as a species, but lots of microbes are far more successful, and there are microbes everywhere. So probably the first form of life we discover will be microbial. And in terms of what kind of microbial life, I think we're most likely to discover life through the so-called biosignature of oxygen gas in an exoplanet atmosphere. And if we find that, then what it means is we're probably finding evidence of photosynthetic microbes, although it could also be plants.
And one question maybe that people listening to this, often ponder is when it comes to our own planet, how did we progress from a microorganism to the world that we are now with, animals and humans? I mean, how did that all develop from a microbe?
Well, Ian, I'm tempted to answer that question with how long have you got?
I thought you were going to say which came first, the chicken or the egg. I mean, I've always wanted a scientific answer to that.
Well, we know that the microbe came before the chicken and the egg. Okay, so maybe the best way to look at your question is, what were the major transitions to get from simple single-celled organisms like bacteria to all manner of animals and plants, including humans? I guess the first step was going from life forms all consisting of just a single cell to life forms becoming multicellular, life forms being composed of many cells rather than just one. And we think that happened a couple of billion years ago. And we think that it happened in particular in the lineage that led to animals by a group of interesting microbes whose name sort of translates as collar cells because they have a little collar and have a little tail as well. And their present-day counterparts are known to be able to gather into balls of cells. And we think that this was the first step, and that eventually these balls of cells became the organism rather than collections of single-celled organisms. And then the biggest next step was to reorganize this into what we call a bilaterally symmetrical animal, which has a head and a tail end and a left and a right side and a back and a front. And once you got that, and we call that really, really simple animal, the Herbalaterium, which is a bit of a mouthful, and so some of us just nickname this Herbie. And once you had Herbie, you can easily then, I say easily, it took a lot of millions of years, but you can easily modify this into a more complex animal by adding appendages and eyes, other things.
And there's your answer. Wow, fascinating. But it just takes a few million years and you're there.
Well, to go the whole way, it unfortunately takes a few billion years.
Which is quite a wait, really, all things considered. Also with us on this podcast today, science communicators from Kielder Observatory, Dan Pye and Adam Shaw. Dan, you have a question for Wallace.
Yeah, I'd quite like to ask a question, actually, because it's a question that that I get asked quite a lot at the observatory, which is there's this theory around life being kick-started or starting as a result of either a meteor impact or a comet impact in the Earth in the very early stages of our planet's formation. Is that something which you support, Wallace? Is there some meat on the bones to that? Or because I never really know how to answer that question, I just kind of go, yeah, it's a theory.
I think you're talking about the theory of panspermia, right?
Yeah, that sounds about right. Yeah.
Yeah. No, I'm absolutely and completely, what's the best word, not convinced by the theory of panspermia. In fact, in my book, I advance the opposite theory, which I call autospermia, which is that wherever you find life on a planet, it has arisen on that planet and not somewhere else. Let me try and explain why I feel that the panspermia theory of life coming to Earth initially from somewhere in space is crazy. Because you can think about it in terms of a Martian meteorite. And there was a Martian meteorite that landed in Antarctica, which people claimed had fossil microbial life in it. Now imagine, how is that life going to get to Earth? What has to happen is some large body like an asteroid or a bit of an asteroid has to land on Mars in order to eject bits of Mars in our direction. So there's an explosion. So first you have to survive an explosion as a Martian microbe. Then you have to survive incredible G-force and friction in the Martian atmosphere. Then you have to survive at the very least 6 months in deep space with all the radiation, the vacuum, the temperature of about minus 271 Celsius and so on. Then you've got to burn up in the Earth's atmosphere, but somehow survive that, and then you impact the Earth. Now, what's the probability of any life form that we know of, or even any life form that we don't know of, surviving that series of events? To my mind, it's vanishingly small. And so if you're proposing that life originates in situ on the planet where you find it, that's already quite a big ask in terms of how did that happen? How do you go from ordinary chemistry to biochemistry? But the theory of panspermia, life coming here from outer space, means that you still have to have those improbable events of chemistry turning into biochemistry somewhere else. But in addition, you need to have the whole extra series of really improbable events surviving a whole series of unsurvivable processes. So my money is on life evolving in situ wherever it's found. And the only exception to that, I think, would be intelligent life which has colonized other planets.
See, going back to the topic of Venus, I do have a question actually, because you've touched upon the different possible locations for life in our solar system, whether it be Europa around Jupiter or Enceladus around Saturn, or there's a few different other candidates. I mean, maybe below the surface of Mars, for example. If you were to put some money on a bet for where we may find microbial life inside our solar system first, which do you think would be the best location, or you'd have the best odds with, I guess?
Well, that's a very interesting question. Of course, I would say it's more likely that we'll discover it on an exoplanet than in our own solar system. But if you really force me to say within our solar system, which would my money be on? It wouldn't be on Venus. I think by this stage, with the amount of exploration of Mars there's been, it wouldn't be on Mars. If we're talking about present day life, past life, I'm not so sure. Past life, I'd be very interested to see what the NASA Perseverance rover discovers. But I think if I had to put my money anywhere, it would be on one of those moons of Jupiter or Saturn. Deciding between Jupiter's Europa and Saturn's Enceladus, I couldn't really do. But how about this? I'll plump for Europa because I love the film Europa Report.
Now, if I remember correctly, is that the one with the giant sea monster?
Yes, it is. It looks a little bit like a large jellyfish.
And do you think that when they do, if they do find life there, that's what it'll look like?
Certainly not.
Wallace, before you go, we should talk about your book, because you have got a new book out, which is very much on the topics we've been talking about, called The Biological Universe. And as you mentioned right at the start, that you didn't arrange this Venus discovery to help promote your book in any way. It's just a coincidence. Tell us more about the book, though, because it is now available in the UK and it's coming soon to any listeners in the United States. It's on the way there very soon. But what are the topics that you're exploring in this new book?
I suppose there are two main themes of the book. One is how widespread the biological universe is. In other words, how many planets life is likely to be found on. And the other theme is, what is the nature of that life? Is it likely to be like us, or is it likely to be completely different? And in relation to that latter question, I actually take a view that it's going to end up being much more similar to us than some people think. Now, when I say us, I don't just mean humans. I mean terrestrial life, life on Earth in general, including terrestrial microbes. And there's one particular debate in this area, which is the debate over what's called carbon chauvinism. And carbon chauvinism, as you might imagine, is a derogatory expression used by people who think that life could be based on some other element like silicon. And it's used as a derogatory expression for those people like me who think that life is almost certainly going to be carbon-based everywhere throughout the universe, which is a very strong statement. And so let me try to defend it, if you like. All of the big molecules on which life on Earth is based, and it doesn't matter whether it's a microbe or a person, all of the big molecules, things like DNA and protein and carbohydrates, all these molecules are huge carbon-based macromolecules. And they're interesting because they have unique sequences. So one gene can be different from another gene because of the DNA sequence. It's not possible, in my opinion, to make sequence-specific macromolecules, these huge informational macromolecules like DNA, on the basis of any form of chemistry other than that based on carbon. And I challenge in the book, and I challenge in general, those people who use the derogatory label carbon chauvinism to come up with an element, silicon or any other element, where you can actually have the basis for a life-giving chemistry as opposed to a rather boring, ordinary inorganic chemistry.
Wow. Yeah, I was going to. One question that came to mind before you actually said that was that if we do find life like us, I mean, are the building blocks of life really that specific that it would turn out very similar to what we know?
Yes, well, as I say, there are different opinions on this. My opinion is very strongly that life would be based on carbon pretty much wherever you find it. As you go up in terms of spatial scale, up from the molecular level to cells and whole organisms, creatures, animals, whatever you like to call them, then it's less possible to be certain. So, for example, I'm as certain as it's possible to be that life throughout the universe will be carbon-based. But if you ask me, is it all cellular, then that's a harder question to answer, because on Earth there are a small number of life forms which are not cellular, and that is, of course, the viruses, including our friend coronavirus. These are subcellular particles just composed of nucleic acid and protein. But they only exist as parasites of organisms that are made of cells. So if Earth's anything to go by, self-sufficient life, as opposed to parasitic life, has to be based on cells. Extraterrestrial life, obviously, we don't yet know, but I guess there's a necessity for any kind of organism to have some sort of boundary between it and the external environment. So if you're going to put a boundary there, which in biological terms means a membrane, then you've kind of already made a cell. So maybe not only is carbon-based life the norm, but maybe cellular life is the norm elsewhere than Earth too.
You've dedicated a huge proportion of your life to this whole topic of life in other worlds, elsewhere in the cosmos. What will you do personally on the day that we find out that there is life elsewhere in space? Because you say it's possibly coming in the next decade or two. How will you celebrate?
I will consume an outrageously expensive wine if we get this information that there is extraterrestrial life. And I'm still hopeful that it might occur in my lifetime.
Here's hoping. Wallace, it's been a pleasure speaking to you. Thanks for joining us in this episode.
And thank you very much for hosting.
And if you'd like to meet Wallace in person at Kielder Observatory later this year, keep listening to this podcast and we'll have all the details before the end. You're listening to the Kielder Observatory podcast. Still to come, we're going to have a look as to what's in store over the coming few weeks or so in the night sky, both in terms of things that you can see at Kielder Observatory and things that you could even see from the comfort of your very own back gardens as well. Right now, though, for a little audio tour. Now, if you haven't been up to Kielder Observatory for a little while, or indeed a few years, lots has changed. Even this year, even through the lockdown times, things have been added to improve your experience at Kielder Observatory. And of course, one or two things have changed as well in terms of social distancing and being able to still operate and get everybody in there and still enjoy the full experience that there is on offer. So I took a trip up to Kielder Observatory. It was during the daytime, though, and I found Dan and Adam in their natural habitats, and they showed me around. So, Dan, what's this noise?
So that is the wind turbine. I was very tempted to say alien spaceship taking off there, but
Yeah, that would be. It's just it's the alien landing pad.
But no, it's the wind turbine. So we generate our own electricity because we're completely off grid. We've got a 2.5 kilowatt wind turbine which is behind us there, and it moves direction with the wind. Has to be doing 5 mile an hour the wind in order for it to be generating electricity. But then that feeds into a bank of 24 batteries, charges the batteries, and then 2-3 kilowatt inverters convert that into a 240 volt power supply that we get into the rest of the building.
We're with Adam. It's a windy day, and where are we now?
So we're at the entrance to the observatory, so about to enter into our main classroom area. So this is where the introduction to the event will take place. And inside here, actually, we also have a very special collection of rocks. We've got our meteorite collection. So some actual rocks from space, some of the oldest rocks that you will ever be able to touch. Connected to this building, to this room, we then do have our 16-inch observatory. So that's the observatory with a big old telescope in there, about 16 inches wide. So straight away, when you enter the observatory, the main turret, or the 16-inch turret, you'll notice that it's very dark.
Currently, it's pitch black. Yeah,
that's the intention. Not pitch black. We've got some little red lights down by your feet, just to sort of, again, for health and safety purposes. But the red light is a thing that, if you come to the observatory at night, you will become very accustomed to, because white light, that will ruin your dark adapted vision, ruin your night vision, and if there's white lights everywhere, you are not going to see the sky up above you. You're not going to be able to see the thousands of stars on the Milky Way, which is the whole point of coming to Kielder. But the red lights, they don't affect night vision, so you can still see where you're going, not bump into anything, either each other or telescopes, and also get some great views of the sky, still see what's up there. Okay, so when I turn the telescope on, so we've got a little switch which turns it on. It makes some little R2-D2 noises. So the observatory itself is about 12.5 years old now. So the observatory opened in April 2008. It was actually originally part of an architectural competition to design an observatory for the northeast of England. This turret, this 16-inch observatory, that's part of the main building, and that was one of the two observing turrets that we do have that were part of the initial building for the site. But there are over 230 entries to design this building. This is the design one which does have these two turrets. But the telescope inside here has changed quite a few times. I've been working at the observatory for just over 3 years now, and this telescope has been the same all the time I've been here, but I think we've had 3 or 4 different telescopes over its 12-year lifespan so far.
So now we've got a view of the sky. As we stand here, it's daylight. Well, we can see the sun. Spotted one bit of astronomy there.
There we go. You see a star. Amazing. The closest star to us. And in fact, the thing about the sun is, right over there, I've got a solar filter. So this telescope is a big 16-inch reflecting telescope. It's got mirrors inside that can collect and focus up light. And the fact that it's 16 inches wide means it can collect a whole lot of light. Now, you don't want to look at the sun with your eyes, let alone with a 16-inch telescope. That is not going to be very good for your eyes. It will make you go blind. Not a good idea. However, we've got a special telescope, looks a bit like a shiny mirror top hat, which goes on the end of the telescope. It blocks out the vast majority of the light coming from the sun, so we can safely observe the surface of it. We've got some software called the SkyX Professional. This is what we use to control the telescope, and it's literally going to be a matter of me typing in the sun, and then the telescope will move to point exactly at that sun. And away it goes. Okay, so we've got the telescope pointing at the sun. I'll wipe down the eyepiece and I'll let you take a look, Ian.
Oh, wow. Yeah. It is a big white disc.
It's just as bright as you imagined it would be. Right, okay, so where are we now, Dan? Because we're out on the poop deck, it looks like, on your ship of the stars.
Yeah. So I guess this is what we would call a poop deck, isn't it? Yeah, we're just about 400 metres above sea level. The other high point is just across from us over there. There's a little tower on top of there which belongs to the RAF, and that's called Deadwater Fell, for what of an ominous name. That's the highest point in Kielder, and allegedly on a very clear day you can see pretty much coast to coast from the top of there. Apparently, we've been up there and it was a clear day and I couldn't see it, but apparently on a really clear day you can. We're going to walk down the side of the building which leads down to the Gillian Dickinson. No, it doesn't. It leads down to the Sir Patrick Moore Observatory. Well, one side does lead to the Gillian Dickinson building, but we're not going to go that way. And then when we walk in, it's a big spiral that we walk around, a gradual inclined spiral, which is good for disabled access. This one is completely disabled access, whereas the other one isn't because of the steps that lead into it.
What's the difference between this telescope in here and the one that we saw in the previous observatory?
So this one is slightly longer, a slightly different style of telescope. It's still a reflecting telescope that we use in here, still a 16-inch reflecting telescope. But the style of this one is very similar to that of the Hubble Space Telescope. It's called a Ritchie-Chrétien style. And it first came about in the early 1900s when astronomers were starting to take images of the sky. And when we started to take images of the sky, because the mirrors that are used in the bottom of these telescopes are curved, what happened was around the outer edges of the image you had stars which were being aberrated or stretched out, so they were becoming long lines of little sausages of stars rather than like nice pinprick stars instead. So a chap came along called Ritchie-Chrétien, decided to change the design of the already existing reflecting telescopes, tweak the shape of the mirror in order to smooth the viewing field out, so you got a lovely field of stars which were pinpricks instead of little sausages around the outsides of them. And that's the style of this one here. So very, very similar to that of Hubble, just a lot smaller. Of course, it's only 0.4 meters, this one, whereas Hubble's 2.4 meters and billions of dollars. This one's probably $6,500. So big price difference.
We're back inside now into this is your newest building, is that right, Adam?
Yeah, so this is the Gillian Dickinson Astro Imaging Academy. So it's actually about 2.5 years old now, but it's a welcome addition nonetheless. We've got some fancy telescopes in here with some CCD cameras in the back, so they're specifically designed, set up for us to do some astro imaging, astrophotography, taking photos of deep sky objects. And not only that, but we've got another classroom and a kitchen. So this is where, during our events, we can serve our hot drinks. usually halfway through the event.
But generally, this is the telescope room, which has some of the most expensive kit that we have in the observatory. It's got cameras attached to the back of telescopes. There's a telescope above your head just there, the small, this medium-sized one. Just here, it's by a manufacturer called Takahashi, and that's actually the most expensive telescope that we have in the building. Only by a couple of £100, but nevertheless, it looks small and insignificant, but it's very, 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 very good quality, and very, very capable of producing stunning images, which is what the thing is attached to the back of it there. It's got a camera attached to the back of it, which is slightly different to a normal camera. It's using a CCD sensor instead of the CMOS sensor that you would normally find in a digital camera. There's a few different sizes in here. There's a 4-inch telescope, a 4-inch refracting telescope, which is the Takahashi one. There's a guide scope attached to the top of that one. Then we've got a 10-inch Ritchie-Chrétien style, very similar to the one in the Sir Patrick Moore Observatory. And then we've got a 14-inch version of that as well. Again, very similar to the one in the Sir Patrick Moore Observatory. That's got a CCD camera on the back of it. Here's the 14-inch one. And a colour wheel because it's monochrome. And the little filter wheel can help us filter out different colours. Adam knows more about colours with filter wheels.
So if you want to take a colour image using the monochromatic CCD camera, what you would have to do is you'd have to basically take an image using the red filter, so you're seeing only the red light, an image taking the blue filter, seeing the blue light, and an image with the green filter. So you can combine the red light, the blue light, and the green light together to get an RGB image or a full colour image. But you can also use specific filters. So, for example, if you had a setup like this in your back garden, which might be a more light polluted area, you could use a specific type of filter to try and filter out street lights. So in the case of old style street lights, that'd be sodium they'd want to filter out, but it's harder now with the LED lighting to filter it all out. Or if you're looking at specific objects, so here, if you want to emphasize hydrogen regions, for example, in a gas cloud, or oxygen, or anything like that, really, you can get specific filters to highlight these regions and see what we wouldn't ordinarily be able to see with our own eyes.
Just some of the sounds you can experience. You can experience the sights for yourself, of course, with a trip to Kielder Observatory. It'd be great to see you here. And there's lots to be looking forward to as well over the coming months. And October kicks off. The first week of October is Space Week. But there's plenty going on at this time of year down in the night sky, isn't there? It's an exciting time of year for astronomers.
Oh, we've got some amazing things that start to come out at this time of year, because now it starts to get into the darker nights. That means we start to be able to see more of the sky for longer. We've got a meteor shower that peaks at the very beginning of the month. The Draconids, or the Draconids, or I'm not entirely sure how that's pronounced, to be honest. It radiates from the constellation of Draco the Dragon. So the meteor shower will probably be best viewed looking in the opposite direction to Draco, because that's where we'll get the longer tails. It's not one of the stronger ones of the year, and it peaks around the 7th and 8th. It's always worth keeping an eye out either side of that as well for about a week and a half, because that just being the peak, the 7th and 8th, doesn't mean that it just happens on those dates. It kind of ramps up and then tails off after and before those dates.
And is there a particular direction that we're best looking in to be able to see these in our gardens?
Well, Draco is probably going to be almost above our heads and slightly towards the north. So I would be probably looking in the south is probably the best opportunity of the longer tails, because although we call it Draconids or whatever it might be called, the radiant point being Draco means that if you look towards Draco, the meteors are coming towards you, so you won't get as long a tail. They're not burning through the atmosphere for as long. So you'll end up not being able to see them very well, essentially. So the further away from the from Draco that we look, the longer the tail has an opportunity to have.
Other things going on then at this time of year. We're around that time of year for aurora, and there have been a few sightings at Kielder, haven't there, over the past week or two. I know that from previous conversations you weren't expecting a massive show from the aurora this year, but nonetheless there have been viewings.
Yeah, they have. There's been some incredible viewings of the aurora in Northumberland and particularly in parts of Scotland as well. It's starting to creep down the globe towards us. The reason for that was there was quite a large coronal hole which was present on the sun and facing straight towards our planet. And what coronal holes are essentially almost like channels of really charged particles which are being spread out into our solar system. Normally, the magnetic field would reconnect within the sun or on the solar surface and bring material back down towards the sun. However, in the case of a coronal hole, it's pushing material out, pushing it into the rest of the solar system, been travelling across the solar system on the solar wind, and then interacting with our planet. And that's enough, in this case, to have driven some aurora here on Earth that reaches a little bit further down the globe than it would do normally.
And basic tips for viewing the aurora then, because we are, if you're in the northeast, there are a few good places to see it. Obviously, not least at Kielder Observatory, but if you're elsewhere, what are the general tips for getting a good aurora viewing?
Dark sky is certainly something that we want is dark skies, preferably away from the moon. The last couple of scenarios where we've had some good aurora, the moon's been out, so we've been battling the light pollution in our atmosphere that the moon causes. So we want it to be nice and dark. Somewhere in a dark sky park would be a good place to go, such as the Northumberland National Park, or even a beach. If you've got a beach which has a north-facing view, then you can look across the ocean, look across the sea towards the north with free from light pollution over there. Of course, it's the water. There's no lights in the water unless you've got an oil rig or something like that in the way. And a nice low horizon as well. We've got a sea level horizon, so we're seeing much more of the sky and maximising our chance of being able to see more of the aurora in an area which is really, really dark.
And if you head online to our social media pages, there's a video on there of how the aurora looks from Kielder, taken not so long ago. And you can see the green light as it appears over the horizon, but certainly something to keep your eyes peeled for. And something that's been a bit of a feature this summer in the night sky is Mars, which you can see even with the naked eye. And that continues to be a feature, doesn't it, Adam?
Yeah, absolutely. So for the first half of October, just each day going onwards, Mars is going to be getting brighter and brighter in the sky until the 13th of October. At that point, Mars will be what's called at opposition. So it will be on the complete opposite side of the Earth to the Sun, and that'll also therefore be this its closest point to us in this part of its orbit. So it'll appear much brighter, and if you've got a telescope, something that we've recently been able to do at the observatory, because it's getting much closer and brighter, is you can actually start to make out some surface details as well. But you don't need a telescope to see Mars. With the naked eye, you'll see it as an incredibly bright. It looks just like a star, but it won't be twinkling. Planets don't twinkle. It will just look like an orange star. You can very clearly see the colour to the planet Mars with the naked eye.
Yeah, I have seen this on a night in the garden. It's sort of like a pinky, like you say, a pinky, orangey kind of star. It's sort of like the south when I've seen it, sort of southern, southeast sort of direction. I think in the sky when I've seen it.
Yeah, so it'll. When it's at opposition, it'll be rising basically as the sun is setting. So middle of October time, as the sun sets, Mars will be rising, and as the night goes on, rising from the east, it'll be getting higher and higher, moving across the sky toward the south. So when it gets really dark, that's when you'll be able to notice just how bright Mars is, and toward the southeast and south is where it'll be best seen, really. But it'll be getting high up the later the night goes.
And more meteor showers as well over the coming weeks. We've mentioned one shower with Dan, and at the end of the month, as we get towards Halloween, there's more meteor showers in the offing as well.
Yeah, so the Orionids meteor shower. So as Dan was talking about, the Draconids or Draconids meteor shower originating from the constellation of Draco. The Orionids is originating from the region of the sky where the constellation of Orion is. So Orion's probably one of the easiest constellations to spot in the sky. It's most prominent in winter time, but later on in the night, during October nights, Orion's going to be getting higher and higher in the sky as time goes on. But on the 21st of October is going to be the peak of that Orion intermeteor shower. But again, like Dan suggested, you're probably going to be best looking away from Orion because that's where those meteors are going to be radiating from. So looking away from them, you'll be looking away from Orion, and you'll likely be able to see some bigger and longer meteors.
Now, coming up over the next few weeks, things very, very busy at Kielder Observatory, and a lot of events are already booked up. But looking further into the rest of the year between now and the end of 2020, all things being equal, and we're allowed to do what we hope we can do. Some events coming up that people can book in for, and we started off this podcast talking about the possibility of life in other worlds with Wallace Arthur, and you can actually meet Wallace Arthur himself, who's going to be talking about this very subject at Kielder Observatory before the end of the year.
So on the 3rd of December, Wallace Arthur is coming to the observatory to join in on one of the events that we run quite regularly. The event is around exoplanets. Discovering New Worlds is the title of the event. And Wallace is going to be the special guest speaker at that event on the 3rd of December. Usually the event would be topicked around the existence of exoplanets, planets which orbit around other stars elsewhere in our galaxy, the detection methods that we go through in order to be able to search for these worlds as well. So we'll probably talk about that in very lightly, but most of the focus topic talk will be hosted by Wallace about his new book, The Biological Universe.
And for more information on upcoming events and to book your place, head to kielderobservatory.org. And don't forget too, you can follow us on social media. Search for Kielder Observatory on Facebook, Instagram and Twitter for the latest news and pictures of the night sky too. And my thanks to Dan Pye and Adam Shaw, and of course our special guest in this episode, Professor Wallace Arthur, for joining us. Be sure to subscribe to the podcast, make sure you get the next episode straight to your device, and if you've enjoyed it, leave us a little rating and review too. It's always great to hear from you. Until next time, stay safe and happy stargazing.